Okay, we're asked to find the derivative of this function from the first principle. Before I solve this, so that you follow up easily, let's go back to the proof, because this is quotient. So let's go back to the proof of quotient rule from the first principle. It will guide this solution. So we asked to prove that h of x is, that's if h of x is equal to f of x over g of x, then the derivative is this. This is called quotient rule. We're asked to prove the quotient rule. So, but before then, if you could remember, the derivative of any function from the first principle is the limit of h tends to 0 of f of x plus h minus f of x all over h. So that's it. But we are giving h of x as f of x over g of x. So in this derivative from the first principle requires 4 steps. The first one, we need to get the change, that's f of x plus h. After we subtract the original, third, we divide by h. Finally, we'll find the limit. So we're going to, okay, let me use white. So we have h of x plus h. So we have f of, so if it's changing on the left hand side, it will be changing in the right hand side. So we've gotten this like this. So next thing is to subtract the original function from this, which is h of x. The same thing, we'll subtract, so minus f of x over g of x. So looking at this, we can get the LCM, which is g of x times g of x plus h. So here is the numerator is g of x times f of x plus h minus f of x times g of x plus h. So let's just look at what we are asked to prove. We are seeing g of x and we are seeing f prime x, but we have f of x plus h. And how will I get f prime x? Look at this. For us to have f prime x, we need to get this. So what do I do? To be able to get this, I'll need to add something and counter it. So if I decide to add or maybe subtract f of x times g of x, I need to counter it by adding. So this is 0 minus f of x times g of x plus f of x times g of x is 0. I just introduce so that we can get this f prime and g prime. That's the only way we can get f prime and g prime. So we'll repeat this, which is f of x times g of x plus h. So all over g of x times g of x plus h. So we are moving. Let's move to the other page. Okay. So we can factor, as you can see, we have g of x. So we have f of x plus h here. That's remaining f of this minus f of x. So that's for this. Y for this one, remember this is minus. So if I factor minus f of x, what is left is g of x plus h minus g of x. So the same thing, we are still correct. I factored g of x and f of x. That's by grouping. So next thing, we need to divide by h. So the next step is to do this divided by h. So which is dividing this by h. So we need to do it fast so that we won't waste time. Remember, this is minus, so it splits this into 2. So I divide each by each. Why our denominator is still g of x times g of x plus h. So we are still correct. We divided both sides by h. Since we have minus, we split it into 2. So the LCM is h. Coming down, we'll have h. But we decided to move it up so that our solution will be easy. I hope you understand. I'm saying that, see what I did. Assuming you have a over b as one term over c. You know it's the same as a over bc. So I can move b up. So that's what instead of writing h down, I moved it up. And since we have subtraction, we'll split it. So each of the numerator will be divided by h. So that's what I did. So the next step is to get the limit. So we have the limit of h tends to 0 of the left hand side, which is that's introducing limit to both sides. So this is the same as the limit. Remember, the limit of addition, subtraction, product, division, you need to get the limit individually. So for this is the limit of h tends to 0 of gx times, we need to write this as one term now, f of x plus h minus f of x over h minus the limit of h tends to 0 of f of x times g of x plus h minus g of x all divided by h over the limit of h tends to 0 of g of x times g of x plus h. So let's still move to the next line, to the next page. Okay, we see that the limit of this is a product. To get the limit of a product, you find the limit individually and multiply. So limit of product is the product of their limit. And also the limit of a constant is a constant. So this is like a constant. So we can write the limit of h tends to 0 of this is g of x. Y the limit of this f of x plus h minus f of x over h. Y the same thing, this is like a constant, the limit of, so we have f of x times the limit of h tends to 0 of g of x plus h minus g of x over h. The same thing, this is a constant, to have g of x, the limit of h tends to 0 of g of x plus h. So what do you have to say? This is now h prime x. That's the derivative from the definition, which you can see from what I wrote before. From the definition, do you see? So everything here is now prime. So we'll compare. So we still have that same thing here. This g of x. Why this is the derivative of f of x minus we have f of x. This is the derivative of g of x over, this is a constant which is gx. If you substitute that, this, you know, the limit by the law, you substitute this as 0. So I have that same g of x, which is now g of x times g of x. So which is that. So we've proved the quotient rule. Okay. We can now see how we solve. So we have f of x to be 7x plus 9 over 3x minus 5. So the next thing is to get f of x plus h, which is 7 times x plus h plus 9 over 3 times x plus h minus 5. So we've done the first part. The second part is to subtract the original function from this one. So we now have 7 times x plus h plus 9 over 3 times x plus h minus 5 minus 7x plus 9 over 3x minus 5. So on this, the LCM is 3x minus 5 times 3 times x plus h minus 5. That's the LCM. So why this is 3x, the numerator is now this times this minus the other one, 7x plus h plus 9 minus 7x plus 9 times 3 times x plus h minus 5. So in the video, if you could remember, we added something. Let's go back so you see what we did. If you could remember that we added, when we got here, this is where we are in the solution, we added minus f of x g of x and countered it. That's, we added and countered it. This is 0, getting back to this. So that's what I will do here. So I will subtract, this is 3x minus 5 times 7x times 7 times x plus h plus 9. So we'll subtract f of x g of x, which is 7x plus 9 times 3x minus, we'll counter it again, 7x plus 9 times 3x minus 5. So this is 0. We just added it to make the solution easy. So before writing this, this is this, why all these two, the sum is 0. So let's repeat this, minus, let's write down, minus 7x plus 9 times 3 times x plus h minus 5, all over 3x minus 5, this minus 5, times 3 times x plus h minus 5. So let's move to the next page. Okay, the next step, if you could remember, let's go back so that we'll be referring to it to guide us. We've done to this level. So what did I do? We've added this. So we'll factor g of x. So let's factor g of x and f of x. So let's factor. So what is common? You see, what is common here is 3x minus 5. So we are left with 7 bracket x plus h plus 9 minus 7x plus 9. So we'll factor this. We'll factor 3x minus 5. So we are left with this minus this. Again, we factor minus f of x, which is 7x plus 9 So we are left with this minus. So this one will be positive. So I have 3 times x plus h minus 5 minus 3x minus 5. So we'll repeat the denominator, which is 3x minus 5 times 3 times x plus h minus 5. So let's simplify a little. Let's reduce. So if you see 7x, if I expand this bracket, 7x minus 7s is gone. So let's repeat 3x minus 5. So 7 times x is 7x minus 7s gone. 7 times, we're left with 7h. There are 7 times h. Y plus 9 minus 9 is gone. So we are done with this one. So why this? We repeat 7x plus 9. So look at the bracket, the same. 3x minus 3x. So we are left with 3h because this is gone. Minus 5 plus 5 is 0. So I have 3h over 3x minus 5 times 3 times x plus h minus 5. So the next step, we divide by h. So that's the third step. We divide by h. So what do you notice? H is common in all. So if I divide by h, we are left with 3x. There is h, there is h. So we are left with 3x minus 5 times 7 minus 7x plus 9 times 3 over 3x minus 5 times 3 times x plus h minus 5. So do you get? The h is common. So when we divided, the h is gone. So the next step is to find the limit. Therefore, the limit of h tends to 0 of x, f of x plus h. Over h. That's what we are required to solve, which is the same as the limit of h tends to 0. Remember, it's a product. So I have 3x minus 5 times 7 minus the limit of h tends to 0 of 7x plus 9 times 3 divided by, divided by the limit of h tends to 0 of 3x minus 5 times 3x plus h minus 5. So the final step. So we'll see that we'll simplify this. So we have, so this is like a constant, there is no h. So I have 3x minus 5 times 7 minus this like a constant, we have no h. So we have 7x plus 9 times 3 over, we substitute h is 0 here, so we have the same thing. So we have 3x minus 5 all squared. So which is, we open up, 7 times 3x is 21x minus 35 minus 21x minus 27 over 3x minus 5 all squared. So we just, you can see that 21x subtracts 21, we are left with minus 35 minus 27, which is minus 62 over 3x minus 5 all squared. So that's the derivative. This is f prime of x. That's the derivative from the first principle. So it's quite a long solution. So just remember, you need to remember the proof. The proof of quotient rule will help you to solve any question on that. Thank you. If you are giving quotient.